This video will cover the topic of GCSE topic of Combined Science and Chemistry. Examination board I'm following is Edexcel, and we will focus mainly on obtaining and using metals. And the video will start with reactivity of metals. The learning objectives are on the screen. You can freeze the screen to see the learning objectives. 4.2 is for higher content also. Okay, so let's start with the next one. Key learning questions in this video will be similarities and differences between the way the metals react with water and acid. What happens to metal atoms when they react? And how do you explain displacement reactions as redox reactions? And this is the higher content. Okay, nice table for you. You can freeze this at this point and do an overview of metals and then reactions with water. We will divide the metals like this. Potassium is the most reactive metal and gold is the least reactive in the list of metals which are shown on the table in front of you in this video. Potassium, sodium, calcium are the most reactive. Magnesium, aluminium, zinc, iron, and copper, silver, gold are the least reactive. And you can see how they react with water, how they react with acid, and the more reactive the metal, the easier it is to lose electrons to become a positive ion. Let's move along then. A couple of other things just to say. Potassium, sodium, calcium react readily with cold water and dilute acid. Magnesium, aluminium, zinc, iron react very slowly with cold water, but react very quickly with steam, and they react with the dilute acid but less slowly than in the case of sodium and potassium. Copper, silver, gold do not react with water or with acids. Reactivity of metals with cold water. You must learn the products here, the general reaction here, sorry. So the general equation for metals with cold water is when a metal is added to water, they form a metal hydroxide and hydrogen. Example, sodium is added to water, we form sodium hydroxide and hydrogen. Magnesium is added to water, you will get magnesium hydroxide and hydrogen. So you get two key things, an alkaline solution because of hydroxide ions and hydrogen gas which would be fizzing. The picture you see would more likely to be something like cesium or rubidium. And the word equation, again, please note the state symbols. Just to highlight the state symbols for you. Sodium is a metal, water, cold water, gas is produced, which is hydrogen. When group 1 metals react with water, a lot of fizzing is observed since hydrogen gas is produced. A learning check, you can answer these questions in your own time. Reactivity of metals with steam, excuse me, the two main products is an oxide is formed and hydrogen gas is produced. So for example, here are the equation. Magnesium plus steam will produce magnesium hydroxide and hydrogen. And your word equation, again, let me highlight for you. Here now, please notice we are using steam. So therefore, it's gas. And the state symbol for water is gas. When magnesium reacts with steam, a white powder of magnesium oxide is produced. Here, a white powder of magnesium oxide and hydrogen gas. So whichever metal reacts with steam, If this was zinc, it would be zinc oxide and hydrogen would be your product. Reactivity of metals with dilute acids. The general equation is metal plus acid will produce salt and hydrogen. Really important here. Some of these we have studied the topic of acids. So please note, when metals react with acids, bubbles of gas are formed, and that's hydrogen. So that is your observation. A good example, zinc plus sulfuric acid forms zinc sulfate and hydrogen, and your balance equation is zinc solid, sulfuric acid AQ, zinc sulfate aqueous solution, hydrogen gas is produced. And really important thing now, the metal atoms in these reactions, they lose electrons. The more reactive the metal, like for example, like sodium, potassium, they lose their electrons much more easily. We will study this in a bit more detail when we study the reactivity of alkali metals, which is an year 11 topic for Edexcel. 3 questions for you to practice. Name a metal that does react with cold water or sulfuric acid. Write a simple equation for the reaction of calcium with water. And write balanced equations for the reaction of magnesium with hydrochloric acid. That's for you to practice. Now, displacement reactions. Definition. A displacement reaction is one where a more reactive metal will displace a less reactive metal. So a more reactive metal is displacing a less reactive metal. Just want to highlight this point for you. More reactive metal displaces a less reactive metal. Magnesium reacts with copper sulfate. You will see magnesium swaps places with copper. Copper is taken out of the solution. That is displacement. Just to go back once more, magnesium displaces copper to form magnesium sulfate and copper. This reaction will not take place if we have copper reacting with magnesium sulfate. That will not happen. Next, learning check. Write word and symbol equation for the reaction between zinc and copper sulfate. Again, you can do this in your own time. Reduction and oxidation, higher content. So if you are not doing the higher paper, you don't have to do this part. However, my suggestion is it's helpful anyway to go through this part of the content. Okay, oil rig. Just remember what oil rig is. Reduction and oxidation is in 2 types. One is to do with loss or gain of oxygen. The other one is to do with loss or gain of electrons. We are looking at loss or gain of electrons. Loss of electrons. Reduction is gain of electrons. Displacement reactions are redox reactions. For example, magnesium. This reaction which we just looked at, in this case, magnesium became oxidized because magnesium lost electrons to become Mg2+. We will look at this on the next slide. This is the now this is an ionic equation only. I'm not going to through how ionic equations are written. That's a but the reaction generally is this. Because sulfate ions stay the same on both sides, we've taken them out. Magnesium loses 2 electrons to become Mg2+. This is oxidation. Copper 2+ gains 2 electrons and becomes copper. This is reduction. Another example, zinc metal can displace copper. Here's the equation. Zinc is above copper in the reactivity series, so zinc loses 2 electrons. Copper 2 plus gains 2 electrons. Zinc is oxidized, copper 2 plus is reduced. As I said, the sulfate ions are neither lost nor gained electrons, so therefore they don't really take part in the reaction, so we ignore them. And here is a good summary for you to have a look at. Oxidation is loss of electrons, reduction is gain of electrons. We will say this is a redox reaction because simultaneous oxidation and reduction takes place. For you to practice, use the reactivity series to predict whether the following reactions take place and explain which substances are oxidized and reduced in this reaction. Please pause the video here. Give yourself some time to do this question, and the answer is on the screen, but I would really prefer it if you paused and went through this yourselves. And that will be the end of lesson 1 on this topic.